Hi everyone, last video for day 3 for week 3. We look at family of curves, meaning, so let's explore. Let's see what happens to this equation r equals 1 plus c sine theta as I vary the values for c. Now nice thing about Desmos is you can still plot in polar axis as well. Okay, right now my c is set to be 0. So c is 0, I'm just plotting r equals 1, which should be a circle, as we have seen, which makes sense because that's what I have here. It's a circle. As I increase r, for smaller values, it just goes higher. Alright, now recall, we plotted this function. We plotted 1 plus sine theta, and it came out to be a cardioid. So it starts getting pinched from below. As I increase this, the pinching makes it into a fold into itself, and you will recall this graph 1 plus 2 sine theta, which we plotted the cosine version, right? We plotted 1 plus 2 cosine theta, which was the snail graph. Then as I increase, the size of this fold keeps on increasing. Okay, so that there is structurally no change in the shape after that. So there is some value here where this folding sort of begins, and that value is 1. And then if I go in the negative direction, it gets pinched from the top and repeats the same sort of behavior. Okay, so it gets pinched, goes back to being a circle, goes down and gets pinched from the top. So again, this is some sort of explorations that you can do using Desmos. And you may be asked to comment upon what are the various kinds of shapes that you see or deformities that happen, and like what values they occur in. For example, here they happen at exactly c equals 1. It changes behavior. You start getting this loop. So maybe you can look at some of the problems on your worksheet and try to make it general. So add this number c somewhere, and then when you type this out on Desmos, there's going to be an option. Here, let me show you. The moment you type like r equals 1 plus c sine theta. Oh, I typed it incorrect, so theta, it's going to give you this option called add slider, and then you can add, and you can also look at make it animate or just slide along and see what it is. That's it for this video. Just short video to tell you that you can actually plot in rectangular coordinates here. I believe, yeah, you can also change this into actually viewing it rectangularly, like that. In which case you can clearly, sort of see what happens. The radius changes from 0 to 2 at exactly pi over 2 and so on. Okay, this is just for you to explore and see if you can find something interesting, or it helps you sort of visualize what's happening when an equation is in polar form. That's it for today. The next day, day 4's video, is going to be another application, and for that we are going to go back into a topic from Math 103, which is complex numbers. So the first half will be sort of revising the properties and what it really means, and then we're going to apply the two things we've learned, trigonometry and polar systems, in order to understand complex numbers better.